Welcome back to Chemistry 101, and you thought you were taking biology. We really can't understand biology without knowing chemistry, because after all, living organisms are just an aggregation of ongoing chemical reactions. In segment 1, we looked at things like the atomic number. The atomic number tells us the number of protons, but also the number of electrons. Because atoms are electrically neutral, they have the same numbers of protons and electrons. We can use that information to determine the electron configuration. We can place the electrons into the various electron shells. This allows us to determine the number of outer or valence electrons. And remember, atoms will react in ways to fill that valence shell. These reactions take the form of chemical bonds. In this unit, we will look and begin examining chemical bonds. Let's begin with some definitions. We will be building some molecules. A molecule is two or more atoms joined by a chemical bond. If that molecule contains two or more different elements, then we would call that a compound. We're going to look at some ways to make chemical bonds. Bonding only involves the outer shell electrons. This is as those atoms attempt to fill their outer shell. So it's only the outer electrons that are involved in reactions and in chemical bonds. We're going to begin looking at two types of chemical bonds, ionic bonds and covalent bonds. This segment we will just look at the ionic bond. An ionic bond is an attraction of oppositely charged particles. These charged particles are called ions. And then in the next segment we will look at covalent bonds. A covalent bond is where the bonding atoms will share valence electrons. An ionic bond. Once again, remember, atoms like to have a filled shell because that's what makes the atom stable and happy. To begin looking at an ionic bond, first we will examine sodium. Sodium is atomic number 11. So it has 11 protons. It also has 11 electrons. So if we take these 11 electrons, we do our electron configuration. We put 2 electrons in the first shell, 8 electrons in the second shell. 2 plus 8 is 10. That leaves one lonely electron that has to go out into the third electron shell. Okay, that third shell can hold up to 8. Right? Sodium would like to have a filled outer shell. So it really has two options. It can give up that 11th electron, and that would make its second shell its outer one, which is filled with 8. And that's exactly what sodium will do. Sodium will lose that 11th electron. So now it only has 10. And now its outermost shell is the second shell, which is in fact full. And so this is going to make a more stable arrangement. And we would call this now a sodium ion. And now this does have a charge. If we look down at the bottom of the diagram, sodium still has 11 protons, and those protons have a positive charge of 1. But now it only has 10 electrons. It only has 10 negative electrons, so we have an overall net charge of +1. So this sodium atom gives up an electron to be more stable, and in doing so, it assumes an overall charge of +1. We call positively charged ions a cation. Let's look at another. This is chlorine. Chlorine is atomic number 17. 17 protons, but also 17 electrons. We can do our electron configuration. If we put 2 electrons in the first shell, 8 in the second shell. 2 plus 8 is 10. That leaves 7 electrons to go out in the third electron shell. That third shell would like to have 8. So chlorine would like to accept 1 additional electron. That would give it 8 in the third shell and would fill the third shell. So what chlorine does, it actually accepts an electron and becomes a chloride ion. This is also going to have a net charge. Again, looking at the bottom of the diagram, chlorine has 17 protons. Those are positive charges. By accepting an electron, it now has 18 negative electrons. So it has 1 additional negative charge, and it will have a net charge of -1. Negatively charged ions are called anions. Okay, now we have made a sodium ion that has a plus charge of 1. We have made a chloride ion with a charge of -1. And now oppositely charged particles are attracted to one another. So this makes sodium chloride. Sodium chloride is just common table salt, and it is an attraction of positive sodium ions and negative chloride ions. These assemble into a crystal lattice or a granule, a crystal of salt. Okay. All salts are ionic compounds. If we place these in water, the water molecules will interact with the positive sodium cation and the negative chlorine ion, and these will dissociate and dissolve in water.